This is your video that goes over the key for Pythagorean theorem practice. For this problem, we are going to first plug in our values into the Pythagorean theorem equation of a squared plus b squared equals c squared. So, we have 5 and 14. These are our legs, and we remember that our legs are represented by a and b. So we have 5 squared plus 14 squared equals c squared. C squared being the squared value of our hypotenuse length, which is what we're trying to solve for. Then we do 5 squared, which gives us 25. And we do 14 squared, which gives us 196. Still equal to c squared. We add those two together to get 221. And that's equal to c squared. But we don't want to know what that side length is squared, we want to know just the side length. So we're going to find the square root of 221, which when we type that in, we're going to get 14.86606, and so on and so on and so on. But your directions say to round to the nearest tenth. So 14.86 would round to 14.9, and that is our final answer for the value of c. For number 2, we're going to start with our equation again, and we're going to identify what values we were given. So we were given 10 and 20, with our right angle being right here. So 10 is a leg, and 20 is our hypotenuse. So we can use either A or B to represent 10. I'm going to choose A. And we're going to substitute in the values we know. So we know that our hypotenuse, which is represented by C, is a value of 20. And we're going to square that. So when I get to 10 squared, I get 100 plus B squared equals 400. We subtract 100 from both sides to get our variable on its own, and then I'm left with b squared equals 300. Then I'm going to take the square root of 300 using my calculator, and when I take the square root, I get b equals 17.3, with us rounding to the nearest tenth as our final answer. For question 3, we're given 5 and 13. Both represent legs, and we're trying to solve for the hypotenuse. So we're going to substitute in those values to the Pythagorean theorem equation over here. We're solving for c. So we're going to change 5 squared to 25 by calculating 5 squared. 13 squared, we do the same thing, equals c squared. When I add these two together, I get the value of c squared being 194. But again, we don't want that value to be squared. We want it to be on its own, so we take the square root. And when we calculate that, we end up with c being equal to 13.9 when we round to the nearest tenth. For question 4, we're solving for a leg, because this side is part of creating our right angle. So I'm going to exchange A, the variable, for 17, the value we know, plus b squared, b being what we're solving for. And then our hypotenuse is 19 squared, and I'm ready to get calculating. So I'm going to start by doing 17 squared, which gives me 289. B squared is going to stay as it is because we don't know that value. And then we're going to calculate 19 squared, which is 361. We then subtract 289 from both sides, which gives us b squared equal to 72. We square root both sides, and when we do that, using our calculator, we get that b is equal to 8.5 when we round to the nearest tenth. For number 5, we're solving for the hypotenuse, so I'm going to substitute in the values I know. So 28 squared plus 96 squared equals c squared. 28 squared is going to be 784. 96 squared is going to be 9,216. All of that's equal to c squared. We're going to add those two values together, and we get 10,000. We then take the square root of both sides, and we're left with 100 equals c. For question 6, we're given our two legs again, and we're solving for the hypotenuse. So I'm going to substitute in what I know. So 65 squared plus 72 squared equals c squared. 65 squared gives me 4,225. 72 squared gives me 5,184. I add those two values together and get 9,409. We don't want c squared, we want c on its own, so we need to remember to square root this value. And when I do that, I get 97 equals c. For question 7, we're given two side lengths and we're solving for the one that has the blank. So what we're going to do is just substitute in these values for our variables in the equation we can use for the Pythagorean theorem. So I'm going to change this to 15 squared plus b squared equals 17 squared. We're then going to multiply 15 squared to get 225 plus b squared, which is equal to 17 squared, or 289. We subtract 225 from both sides, and when we do that, we're left with b squared equals 64. We don't want b squared, we just want the value of b. So we're going to square root both sides, and we get b equals 8. Again, they give us values for our side lengths in number 8, and we're solving for that blank for variable c. So a squared is going to become 11 squared, b squared becomes 16 squared, and we're solving for c. We're then going to change these to their values, so 121 plus 256 equals c squared. We add those two values together and get 377 for the value of c squared, but we want just c, so we're going to square root both sides. And when we take the square root of that and round to the nearest tenth, we're left with 19.4 equals c. Squared. Same process as 7 and 8. We're given values. We're going to start by substituting them into our equation. So we don't know the value of a, so it's going to stay a squared. B squared is going to become 2 squared, and c squared 4 squared. Then we're going to simplify our expression here by taking those exponents out. Then we subtract 4 from both sides. We're left with a equals 12. We're going to take the square root of both sides, and when we do that, we get the square root of 12 is 3.5 when we round to the nearest tenth. For our last question, we're provided the side lengths of b and c, and we're solving for a. So we can start by substituting the values we know into our equation. So we get a squared plus 20 squared equals 45 squared. Then we can simplify our expression by doing 20 squared, turning that into 400, and 45 squared, giving us 2025. We then subtract 400 from both sides to get our variable on its own, and we're left with a squared equals, we subtract those to get 1,625. We want a, not a squared, so we're going to square root both sides, and we get a equals 40.3 when we round to the nearest tenth.